Hey there, math enthusiasts. Have you ever heard of the Banach-Tarski Paradox? It's one of those mind-bending mathematical concepts that seems to defy all common sense. So, let's dive in and unravel this fascinating paradox together. In simple terms, the Banach-Tarski Paradox states that it's theoretically possible to take a solid sphere, like a ball, and divide it into a finite number of pieces. Then, using only rotations and translations, no stretching or bending, you can reassemble those pieces into two identical spheres, each the same size as the original sphere. Sounds like magic, right? But trust me, it's pure math. Here's how it breaks down. Imagine a sphere, a simple 3D object like a ball. In the Banach-Tarski paradox, you're allowed to cut the sphere into a finite number of pieces. But here's the twist. These pieces aren't simple geometric shapes. They are non-measurable sets, which means they're so peculiar that they can't even be assigned a well-defined volume in a traditional sense. These sets are constructed in such a way that their properties break the rules of classical geometry. Once you've cut the sphere into these strange pieces, you don't have to glue them back together. Instead, you just move them around using only rotations and translations. And voila, you end up with two identical spheres, each the same size as the original. Crazy, right? So, why does this happen? The Banach-Tarski paradox arises from a combination of infinity and set theory. We're working with infinite sets and highly abstract mathematical concepts. The pieces we cut the sphere into are formed by an infinite number of points. And when you use rotations and translations, you rearrange these points in ways that don't make sense in the physical world. The key here is the axiom of choice, which allows you to make selections from infinite sets in ways that might not seem intuitive. This axiom lets us create these non-measurable sets, sets that don't have a well-defined size or volume. And that's crucial because it means we can split the sphere in ways that wouldn't be possible with physical objects. Infinity plays a huge role in the Banach-Tarski paradox. The paradox relies on the fact that the sphere can be divided into an infinite number of tiny pieces that don't behave like familiar shapes. In our physical world, if you cut something into smaller pieces and rearrange them, they'll always add up to the original size. But in the world of pure mathematics, where we work with infinite and abstract sets, this isn't necessarily the case. So why doesn't this apply to the real world? The Banach-Tarski paradox doesn't apply to physical objects because it relies on the existence of non-measurable sets and infinite divisions that don't align with how matter behaves in our universe. It's an interesting theoretical result that highlights the difference between mathematics and reality. In conclusion, the Banach-Tarski paradox is a mind-bending result from geometry that showcases the strange, counterintuitive nature of infinity and set theory. It shows us that in the abstract world of mathematics, things don't always behave the way we expect them to based on our physical experiences. While it's not something you'll encounter in the real world, the Banach-Tarski paradox serves as a fascinating example of how mathematical theory can challenge our intuition and open up new realms of understanding. Thanks for watching. Don't forget to like, share, and subscribe for more mind-bending math content.